Hello friends, myself A.K. Agrawal, Professor of Physics. Today we will discuss how we multiplied two vector quantities. When we are going to do the algebraic operations of the vector quantity, so we will do it by one. First of all, we have to multiply a scalar quantity with a vector quantity. How a scalar quantity is multiplied with a vector quantity? Suppose I'm just writing down a vector A in its component form. Suppose it is like 2i cap plus 3j cap minus k cap. If you want to multiply this vector with a scalar quantity, say lambda, then what should be the resultant? So if you want to find out the resultant, you have to write, let it be B. B is the resultant of multiplication of a scalar quantity with a vector quantity. It should be lambda into A vectors. First of all, we have to understand this. When we multiplied a scalar quantity with a vector quantity, the resultant vector should have the same direction as the vector A. It means there should be the like vector. Their direction are same. And the magnitude of B, if I will talk about the magnitude of B, which is denoted by the putting the modulus across the B, should be equals to lambda times of modulus of A. So in this way you can say when a vector quantity is multiplied with a scalar quantity, you get another vector quantity whose direction is same as the vector A, and definitely the magnitude is lambda times greater than the vector A. So in general form I can write 2 lambda I cap plus 3 lambda j cap minus lambda k cap. So this will be the resultant of when a scalar quantity is multiplied with a vector quantity. Now we will operate a second case where a vector quantity is multiplied with a vector quantity. Why we are saying it a scalar product? When I am just going to multiply two vector quantities. It is worth noting, when we multiply two vector quantities, sometime the product obtained by us is a scalar quantity and sometime the product is a vector quantity. So according to the requirement, we classified this product into two types. First one is scalar product, which is also known as the dot product, and the second one, because the resultant is a vector quantity, we termed this vector product, or we simply represent it by cross product. So we will deal it one by one. How a vector quantity with multiplied with another vector quantity gives us a scalar quantity. So in that way, scalar product, I am just saying scalar product, or you can say a dot product. First of all, if I have two vectors, vector A and vector B, I am just representing these two vectors, and now I have to find out the product of these two vectors. They may be any physical quantities. So first of all, when two vectors are given, we made these two vectors co-initial vectors. What? Co-initial vector, which is originate from the same point. So I just write it like B vectors and A vectors. If you want to find out the angle between these two vectors, you have to make these vectors co-initial, and now this angle between the two vectors is known as the angle between the vectors. Suppose these two vectors when multiplied will gives us a scalar quantity. For an example, work is defined as the dot product of force and displacement. Here force and displacement are the vector quantity while work is a scalar quantity. So here is a simple example how two vector quantity will gives us a scalar quantity. Now how we operate it, how we will get the answer now. So if I will get a scalar product or dot product, I have to write A dot B should be defined as the magnitude of A into magnitude of B into cos theta. Here cos theta, theta cosine of the angle and angle between the vector A and B. So in this way, this is the defined as the scalar product. A dot B should be equals to magnitude of A, magnitude of B and the cos theta. Theta is the angle between the vector A and vector B. Okay. Now I'm just taking an example. Suppose I'm just taking a vector A which is simply 2 cap plus 3. Okay. I'm just taking an example where a body is placed on a rough surface and a force of 10 Newton is applying horizontally, or simply a displacement. This force cause a displacement of 10 meter along the same direction. Now simply I'm just saying force should be 10 Newton along horizontal direction and displacement is also 10 meter horizontally, or I can say along x-axis. If I am considering x-axis, it is along x-axis. Now because both the vector quantity force and displacement both are in the same direction, the angle between these two, if I will make it co-initial, the angle between two will be equals to 0. If both are co-initial in the same direction, the angle should be 0. So what should be the work done? Work done should be equals to F vector dot S vector. Simply I have to say, if I will write down the formula, F dot S should be equals to Fs cos theta. Now what should be the magnitude of force? This is 10 Newton. So I have to write 10. Displacement is 10 Newton. I have to write 10. And what is the angle between these two? Definitely the angle between these two will be 0. So cos 0 is 1. So I have to write 100 joule. So in this way, here two vector quantity will give you a scalar quantity. Sometime, if here it is worth noting that there are certain unit vector which is defined along the x-axis, y-axis and z-axis. So if a vector is given in terms of its component forms, or I'm just getting the product of two unit vectors, now we will define how to get a dot product. So I'm just saying, if two vectors A dot B, if you want to find out A dot B, it should be magnitude of A, magnitude of B and the cos theta. Sometimes you have to, given the vectors A, like vector A will be equals to 2 cap plus 3 cap plus 4 cap, and another vector B B is given by I cap minus j cap plus k cap. So here, how can we find out the angle between the two vectors? Find the angle. Find the angle between the vectors. Clearly, I have to find out the magnitude of A, which is modulus of A. How can I find out the magnitude of A? It will be under root of, I have to square the 2. This is 2 square plus 3 square plus 4 square. So when I simplified it, 4 plus 16, 20 and 29. So the magnitude of A will be equals to under root of 29. If I want to find out the magnitude of B, it will be modulus of B, which will give us 1 square plus minus 1 square plus 1 square. Definitely the product or the simplifying, we get under root of 3. Now if I want to find out the cos theta, it will be A dot B divided by magnitude of A and magnitude of B. Here, if you want to find out the angle theta, you have to write it like cos inverse A vector dot B vectors divided by AB. Here, the magnitude of A and B is already calculated. The another one is how we get a dot product of these two. Here it should be understand what should be the product when I multiplied I dot I. I cap dot I cap. I cap is a unit vector along the x-axis. Any unit vectors has the magnitude of 1. So if I will apply the formula 1 here, what should be the magnitude of 1? It should be 1 I cap. The magnitude of second I cap is also 1. And the angle between the two same vectors is 0. So it means I have to write it here cos 0, because I cap and I cap both are the same vectors. So the angle between these two vectors should be 0. So when I multiplied it, I will got 1. In the same pattern, I got j vector dot j vector is equals to 1 and k vectors dot k vectors should be equals to 1. It means I dot I will be 1, j dot j will be 1 and k dot k should be 1. Now what happened if I multiplied two perpendicular unit vectors like I cap dot j cap? I cap definitely a unit vector along the x-axis, j cap is a unit vector along the y-axis. X-axis and y-axis are perpendicular to each other. So the angle between these two vectors should be 90. Now if I will proceed 1 plus 1 into cos 90. Now I will ask you a question. What is the cos 90? Cos 90 definitely it is 0. So if you write 0 here, you got 0. It means when two perpendicular vectors got into dot product, the result will be 0. In the same pattern, when j cap dot k cap will give you a 0 answer and k cap dot I cap will give you a 0. So now you understand how to multiply the two unit vectors. Now I will multiply A and B. A vector dot B vector. So first of all I have to write the value of A cap, that is 2I cap plus 3j cap plus 4k cap dot I cap minus j cap plus k cap. Now you have to multiply the vectors where you have to open the bracket. When you multiply it, when you got I cap dot I cap, it will be 1. When you got I cap dot j cap, it will be 0. Similarly, I dot k gives you the 0. So only I dot I will give you 1. If I will proceed, then I will got 2 for I cap dot I cap and j dot j cap will give you 1. J dot and I dot will be 0. So you get minus 3. In the same pattern, if you proceed, you get 4 for k cap dot k cap. The final, if you add these 6 minus 3, it will be 0. It means here the dot product of these two value comes to be 3. Now if I will put this value here, this theta will becomes cos inverse, this value will be 3. And what is the magnitude of A? We have already calculated. This magnitude comes to be under root 29 and B is under root 3. So here you got the value of theta. This is cos inverse 3 by under root of, and if you multiply these 3 you got 87. So in this way you can find out the angle when you got the dot product of two vector quantities. We will discuss the scalar product of two vector quantities here. As we discussed, when we got dot product of two vector quantities, suppose I have got two quantities A vector dot B vectors. Sometimes these two vectors when multiplied gives us a scalar quantity. Let this quantity is C. See, here you can see I am not putting an arrow over C, it means it is a scalar quantity. And as we discussed, the formula for A dot B will be equals to A magnitude of A, magnitude of B, and theta. What is theta here? Theta is the angle between the vectors A and vector B. How can you find out this theta? You have to make the two vectors co-initials, and when these vectors made co-initials, the angle between the two vectors will give you the angle between the vectors. Now here there are certain cases where the resultant quantity is either positive, negative, or it is equals to 0. Whether the product of two vector quantity will give you lead to a positive quantity, negative quantity, or the 0. Clearly this C is depending on magnitude of A, magnitude of B, and the angle between the two vectors. So I am just taking a case 1. In case 1, I am just rubbing it out. If I am taking the angle between the two vectors as acute, it means the theta between the two vectors is taken between the 90 to 0. Acute. Cos theta in the first quadrant will be positive, greater than 0. So it means C, when I will apply the values, C will be positive, means the resultant should be positive value. It means if the angle between the two vectors which are going to be a product scalarly, its magnitude comes to be positive. Now I am just considering the another case, case 2. If the angle between the two vectors is 90, means if two vectors are made perpendicular to each other. Clearly, if theta is 90, cos 90 will be 0. And if you apply this value in the dot product form, you can get C will be equals to 0. It means if a question is arise whether a dot product of two vector quantity will be 0, yes, it will be. When the angle between the two vectors will be 90 degree. So it is very important what should be the angle. So whenever in the any competitive examination it is asked what should be the value or the dot product of these two quantity, you have to take in care to consider the angle, because if you are wrongly consider the angle, the data will be reverse. Now I am just considering another case, third. In third case, if the angle between the two vectors will be obtuse, means greater than 90, it means it is lie in the second quadrant. If it lie in the second quadrant, cos value of cos will be negative. It means cos theta will be less than 0. Negative value. If you applied the negative value here, you can get the C will be negative. C will be less than 0. It means the dot product of two vector quantities may either be greater than 0, 0, or less than 0. Negative. I'm just taking a very simple cases. Suppose there is a thread, a mass is hanging by this thread. If I will consider the work done by the tension applied on the block is in upward direction, and suppose this block is lowered down by the thread if it is moving downward by distance t. Now, taken very careful what should be the angle. You can see tension is in upward direction, displacement is in downward direction. These two are moving opposite to each other. It means vectors are opposite. The angle should be, if you made these two vectors co-initial, you get the angle between them will be 180 degree. Yes, angle will be 180. If the angle is 180, if you will put here, work done should be, you know the formula, tension dot displacement. It means tension, displacement and cos 180. The value of cos 180 is -1. If you applied here, you get minus tension into D. So very clearly the work done by tension here is negative. So you have to take in care when you applied this. We will discuss now the vector product or the cross product. Basically, when we multiplied two vector quantities, sometime we got a vector quantity. I'm just taking an example of torque. When we multiplied a force with the position vectors, we got a cross product of it, we get torque. Torque is a vector quantity here, but when we got a dot product of force and displacement, we got work. So sometime multiplication of two vector quantity gives us a scalar quantity. Sometime multiplication of two vector quantity will gives us a vector quantity. So for vector quantity, we defined another multiplication which is known as vector product or the cross product. Because I'm just putting a sign of cross, that's why it is also called cross product. So here I will write C vector will be equals to vector A cross vector B. Here you can see the cross product of vector A and B will leads to give a vector C. Here it is vector, and the formula for A cross B vector will be equals to magnitude of A, magnitude of B into sine theta into n cap. Here n cap, I just put n cap, which is a unit vector which is normal to the plane of the vector plane which containing the vectors A and B. It means this n cap is perpendicular to the plane containing the vectors A and B. Okay. Here you can see this C vector is parallel to n cap. So I can write C vector is parallel to n cap. And this n cap is perpendicular to the plane of vector A and B. Because it is perpendicular to the plane of A and B, so it is also perpendicular to the vector A, and n cap is perpendicular to the vector B. Sorry. So if n cap is perpendicular to A and perpendicular to B, in other words, I can say the vector resultant vector C is perpendicular to A and C is perpendicular to B also. So it means and when we have two vector quantity which are perpendicular, it is already discussed that the two vector quantity which are perpendicular to each other, when we got a dot product of these two, it means scalar product, it will give us a 0. It means the dot product of C vector and A vector will be equals to 0. Similarly, you can write C vector dot B vector will be equals to 0. It is worth noting that if two vectors are perpendicular to each other, their dot product will always comes to be 0. In 12th standard you will study that magnetic force is always perpendicular to the velocity. So when you got dot product of magnetic force and the velocity, you get 0. It means power or work done by magnetic force will always be 0 if there is only magnetic field in that case. Now n cap is perpendicular to the vector of A and B. Now how can you find out the angle? Similarly, I have said again, you have to draw the two co-initial vectors and you have to find the angle between these two. Now, what is the direction of n cap? We discussed the direction is perpendicular to the plane. But how? In which direction? Here the vector A and B are drawn in the plane of board. So first of all, to find the n cap, you are just taking a nail, put it perpendicular to the board, and if you are going to find A cross B, you have to rotate the nail from A to B. If you turn it like A to B, if you rotate it from A direction to B direction, A से B की तरफ जाएंगे, then the movement of the tip of the nail is found to be moving inward to the board. So this movement of the tip will give you the direction of n cap. Here clearly it means A cross B. Here when I move from A to B, if I rotate from A cross B, the direction of n cap should be in inward to the plane of the board. It means here for any inward sign you have to put a cross. If you will put a cross, it shows the vector should leading into the plane of the paper. If you put a dot and encircled it, it shows the vectors is coming out of the board or the plane of paper. So you have to must recognize these two signs. Either cross leads into the papers, dot leads outward to the papers or the plane. Now I think this is very much clear. Now I will take an example how you got a cross product. For an example, if I will take I cap cross j cap. I cap is a unit vector along the x-axis, j cap is a unit vector along y-axis. If you got the cross product of it, you know the formula, A vector cross B vectors will lead you A magnitude of A magnitude of B into sine theta into n cap, which is perpendicular to these two vectors. So I cap, magnitude of I cap is 1, magnitude of j cap is 1, and into sine angle. What is the angle between the x-axis and y-axis? Clearly it is 90. So when you place 90 here, you got 1. Now the another part, what is the n cap here? So if this is I cap, this is j cap. If this is I cap, this is j cap, you can take k cap is outward. If you put a nail here and rotate it like from I to j, you find this tip is moving outward. It means along the k cap. So it leads to a quantity unit direction of k cap. So when you multiplied it, you got k cap. Or for simplicity, you can encircle it. You can take a circle, place I cap, j cap and k cap here, and you can find if you multiplied I, if you move from I to j, you got k cap. If you move j to k, you get I cap. If you multiplied I cross j, you got k cap. If you move from j cross k, you got I cap. If you multiplied cross k cross I, you got j cap. But what will happen if you move anti-clockwise? If you move anti-clockwise, suppose if you are moving from I cross k, if you are I cross k, definitely if the direction of rotation is reversed, the movement of nails will be reversed. So you get minus j cap. The direction is the magnitude, resultant magnitude would be negative here. So now you understand I cross j should be equals to, in the similar pattern you can find any cross product from this part. Now what will happen if you multiplied I cross I? Clearly here I have already told you the two unit vector, similar unit vector have the angle 0. So if we place 0 in place of theta, the value of sine 0 will be 0. It means when you cross product it, you can get 0. Similarly, j cross j equals to k cross k. So now very much clear, if you cross multiplied two identical vectors, you got 0. If you multiplied two perpendicular vectors, two unit perpendicular vectors, you can get another unit vectors which is perpendicular to both of these two vectors. Now I will take where this cross product is useful to us. In many of the quantities, how we can got cross product of two quantities, I just writing down a simple formula. Torque will be equals to R cross F. Here R is the position vector, F is the force. If I will write it down in the form of components, R vector will be equals to Rx I cap plus Ry j cap plus Rz k cap, and force is in the form of Fx I cap plus Fy j cap plus Fz k cap. If you write it down like this in the form of components, and if you want to find out the torque, how can you find out the torque? You have to cross multiply these two vectors. How you got that cross multiplication? So there is a formula, particularly you have to solve this by the determinants method. For this you have to put the unit vector first. In the first row you have to put I cap, j cap, k cap. In the second row you have to put the constant of position vector, here Rx, Ry and Rz. So Rx, Ry and Rz, and in the third row it is the force, components of force. So you have to write it down like this first, then I cap. Now you have to multiply it. So for I cap you have to hide the row and column of I. So if you hide this, you can get this. Now you have to multiply this one and cross multiply it, the remaining part. So if you multiply these two parts, you get Ry into Fz minus Rz into Fy. So first of all you have to write I cap, then cross multiply the remaining, then minus j cap, then again you have to hide the row and column of the j vectors. So if you hide the column of j and row of j, you remain some part of the determinants is remaining. So now you have to multiply Fz with Rx and Fx to Rz. So now the fill comes to be Rx into Fz minus Fx into Rz in the same pattern, plus k cap. So again you have to hide the column and row of the k cap. So if you hide this, you again get Rx into Fy minus Ry into Fx. So this is the method how you multiplied to cross multiplied two vector quantities. I can take an example here, but you have to do it by your own, take in a numerical values in place of R and F, and you find the values. Where it is used, as I have told you, so many formulas like torque should be find out by R cross F. Sometimes area, how can area up to a lower standard we feel area is a scalar quantity, but on the later stage area we have to study the area factor. How can I find out the area vectors? If suppose, so if you want to find out, use area of parallelogram. Suppose I'm just taking in parallelogram where two adjacent side of the parallelogram is represented by two vectors, A vectors and B vectors. And if I want to find out the area of this parallelogram, then area vectors will be given by A cross B. definitely the area vector should be perpendicular to the plane of the parallelogram. And if you want to find out the values, you can get A cross B. And if you want to find out the magnitude of this area, you have to find out the magnitude of A cross B. If you have a triangle, suppose in the triangle, two adjacent side of this triangle is given by two vectors. Again, co-initial vectors, the vectors which is started from the same points. How can you find out the area? Again, I have to write this is half of A cross B, magnitude of A cross B. And how can you find out the A cross B, which is already mentioned here? So by this way, you can find out the cross product of two vector quantities. Thank you.